let's take a quick review of what a mole is and how to determine molar mass. And then in the next videos, we'll learn how to convert amounts. So let's review. A mole is a term we use to describe this many, 6.02 times 10 to the 23 of any object or item. That's Avogadro's constant. How large is it? 1 mole of hockey pucks would equal the mass of the moon. 1 mole of basketballs would fill a bag the size of the Earth. So it's pretty big. So if you look at a basketball, you look at the size of the Earth. The Earth is 1 mole of basketballs in size, not in mass. 1 mole of pennies would cover the Earth a quarter mile deep, the whole Earth. Quarter of a mile deep. That's what, about 400 yards deep, 400 meters deep? Yeah, that's a lot of pennies. I don't even know how much money that would be worth. So you can see here that a mole of carbon is 12.01 grams and a mole of sulfur is 32.06 grams. So 1 mole of carbon and 1 mole of sulfur. Both samples contain the same number of atoms, 1 mole. Since the atoms are different, the mass and volume of each sample are also different. The amounts of the two substances in moles is the same, right? Sulfur has larger atoms that have more mass each, so sulfur takes up more volume and has more mass for 1 mole of it. The important concept that you need to remember is molar mass. The mass in grams of 1 mole of an element or compound. So you can see here in your carbon atom, you have the atomic number. That's 6. That's the number of protons. And then right here is the atomic mass. And this number means that there are, in 1 mole of carbon, there is 12.0107 grams. Now, an interesting question you might have is, why isn't it exactly 12 grams? It's a good question. I'm not going to answer it now, but it is a good question. Because typically carbon has 6 protons and 6 neutrons. That's 12 things in the nucleus. So why isn't this 12 grams? And the reason it's not, I'll answer it a little bit right now, is because sometimes there's carbon-13, and carbon-13 has 6 protons and 7 neutrons, so it's a little heavier. So this is the mass for a typical mix of carbon. If you find carbon around, it'll have mostly carbon-12 in it, which has a molar mass of 12 grams. It'll have a little bit of carbon-13 or carbon-14 in it, both of which have different molar masses than carbon-12. So in a typical mix of carbon, you'll get this molar mass. All right, so chemists use the symbol big M to represent molar mass. I am not going to do that because I don't think it's appropriate. I use the little MM because big M means something else in this unit. And we don't want to confuse big M here with that big M. With the chemical or symbol or formula as a subscript, so I just do this differently just for fun, just because I don't like using the big M. So molar mass of H2O. The molar mass is measured in grams per mole. So let's find the molar mass of, I usually write it like this, molar mass of CO2, just so I'm not using the big M. It's just, I don't like it because big M is used later on. So CO2, we know that the carbon part is 12.011 grams per mole, and there's 1 carbon atom, so it's 12.011 grams per mole for the carbons in this. Oh, there's 2 oxygens. Oxygen's 15.999, and there's 2 of them. So the total mass of the oxygens in this mole of carbon dioxide is 31.998 grams per mole. So to figure out the total for CO2, we just add these up. 900, carry the 1 here for 44.09 grams per mole. That means that 1 mole of CO2 weighs approximately 44.009 grams. Now, it's not exact because it can't be exact because we're dealing with things so tiny, but this is pretty darn close. And what this 1 mole means, this means if I have 6.02 times 10 to the 23 molecules of CO2, then I will have that much mass. All right, so the next example, we're going to find the molar mass of KCl. All right, so KCl, potassium chloride. The molar mass of KCl, this one's pretty simple. We just find K. So we look for K, and it is 39.098 grams per mole. I don't have to worry about multiplying because there's only one K and only one Cl. Cl is 35.453 grams per mole, for a total of 11, carry the 1, 15, carry the 1, 5, decimal 14, carry the 1, 74.551 grams per mole. Right, so if I have KCl and I want exactly 1 mole of it, so I want 6.02 times 10 to the 23 KCl atoms, molecules, then I need to measure out 74.551 grams to get about that amount. All right, so we're just going to talk about this a little bit. The mass of one atom. The atomic mass is the mass of one atom. We don't really care about that too much in this course. It's measured in atomic mass units. The mass of one carbon atom is 12.0107 units, where 1 unit is 1.661 times 10 to the minus 24 grams. So this is just a conversion rate that you could use. What is the mass in grams of one carbon atom? So if one carbon atom is 12.00107 U's, it's an average carbon atom, then how many grams would that be? Okay, so we set this up as a conversion. So we know our U's and we want to find grams. Right, we know our U's is 12.0107 U for carbon. How many grams is that? Here's our conversion rate. So we don't know our grams, so grams goes on top. How many grams are there in 12.0107 U if there are 1.661 times 10 to the minus 24 grams in 1 U? So we're going to take this times this and we'll get our answer. So the number of grams will be something, and I need a calculator for this. I need a calculator that I can work with times 10 to the minus 24 easy. So I've got a special calculator that I use. I'm going to clear everything. Okay, so I'm going to do 12 point, here's my calculator that I use, 12.0107 times Oh, I'm going to put this in brackets. 1.661 times 10 to the negative 24. I get 1.995 times 10 to the minus 23. That's how much one atom of carbon weighs. All right, the important thing is that you remember what a mole is, that a mole is a number. It's a number of something. We have molar masses to convert from mass, which is something you can measure, into moles, which is a counted amount. Every atom, every molecule has a different conversion rate. We have to find the molar mass to figure out that conversion rate. All right, thank you for watching this one.